Have you ever wondered how call centers analyze their recorded conversations? Well, if you're wondering, I'm going to show you in this video how you could analyze and also perform data visualization using the speech AI large language model from Assembly AI. And we're building this workflow in Python. And so if this sounds like fun, let's dive in. All right, so first thing that you want to do is you want to open up this Jupyter notebook. I provided this in the GitHub repository on my own GitHub profile, Data Professor, and then you could browse to the Assembly AI repo here. So here we had a collection of 3 recent tutorials showing you how to implement all of these in Python. There are other tutorials on the channel, so if you go to my YouTube channel, and then you could, search for it. Welcome. So here you could search for Assembly AI, and this will provide you a glimpse at how you could build your own workflow. So here we have a couple of videos already on the channel, and the collection is pretty much growing here. So do check out the prior videos as well. And I'm going to provide you the link to this particular playlist in the video description. And here in the repo, you could download the fourth Jupyter notebook here. It's called For Call Center Analytics. And make sure to also download this to your local computer. But if you don't want to, that's okay, because we're also going to read it live directly from this repository. Okay, so first things first, click here. And then you want to download the link. When you download it, it will be into your computer, and then you could upload it into the Jupyter notebook. Here we're using Colab from Google, so you could go ahead and open it up. You could upload the notebook directly from your own computer. And so pause the video and resume once you have done so. So I'll assume that you have already uploaded the notebook, and so let's continue. So as mentioned here, the tutorial will provide you with a walkthrough of how you could build end-to-end a simple call center analytics workflow in Python. And we're essentially going to do the following here. We're going to take the audio that you're going to download from the repository, and the audio is a recording of the call center agent talking to a customer. And then from the audio here, once we download it, we will feed it to the Assembly AI API. And then once we have done that, it will transcribe the audio, and then we're going to apply our workflow on it. And so particularly, we're going to be able to identify speakers. We'll be able to analyze the sentiment of the audio conversation. And finally, we're going to take that audio data, we're going to convert it from an unstructured form, and then we're going to make it into a more structured format. And then finally, we're going to visualize the audio sentiment data. And so first things first, go ahead and pip install Assembly AI here. So you'll notice that that's going to be the only dependent library here. And the others are already in the Colab notebook. So it is already pre-installed. So once you have installed that there, go ahead and click on the link in the video description, and you should be able to find the link to sign up for an API from Assembly AI. And I believe they provide $50 free of tokens usage. And so go ahead and sign up for it. It's pretty simple. You could click on Get Started, and then it will, take you to the sign up page. Since I have already done so, I'm logged in into my account. And so once I'm logged in, you're going to see the quick start here, and it provides you with pretty much copy pastable code snippet that you could just, copy it, and then you could get started right away. And they already provide you with some example audio file here, and the API key is already provided here as well. So you could essentially just copy paste this into your own Python script, run it, and then you'll be able to see the example. Okay, so go ahead, once you signed up and then logged in the left menu bar here, click on the API keys. And then for here, I've already created a few API key for the project. If you haven't already done so, you could click here on Create New API Key. And then you could provide it a name. Or one API key. And so it could be whatever name that you want to give it. And then just click on Create. And then it will create the API token. And then you could just click here to copy. And then you're good to go. So I'll just delete the newly created one. And it's asking me to retype the name. Okay, cool. I think we're good here. And I'm going to delete this. So if you have seen it, no problem. Default. Okay. There you go. So we're good. So let's head back to the tutorial. And you want to notice that I have the assembly AI key token already loaded in here. If you haven't already done so, click on Add New Secret. And then you could type in AI_key like what I have already done so. And then you could paste in the API token that you have copied. And then once you have done so, you could just activate it by clicking here on the toggle. And then when you want to use it, so let's say I'm going to use the AAI key here. You could just use this block of code here, copy it. I'm going to show you inline how it looks like. So it's going to look like this. So essentially, we're importing the user data function from Google Colab. And then we're going to use userdata.get and then the name of the API key, which is AAI_key. And then we're going to assign it to the AAI_key variable. And then that will then be, provided to the API key function from assembly AI. Okay, so I'll go ahead and load in the prerequisite libraries. And then we're going to load in the API token here as well. Now we're going to instantiate the transcriber, which will allow us to transcribe the text from the audio. All right, so as I mentioned earlier on in the video, the call center recording is provided as an audio file here in the repository. You might have seen it already right here. So let's load the one from the call center. You could also click here, and then you could essentially click here to upload any other audio file from your own computer, and make sure that it is a conversation so that you could apply the speaker label mapping functionality that we'll show in this video. Okay, so we've loaded that in to the audio input variable, and then we're gonna load in the widget that will allow us to hear the audio. So now I'm going to open up my speaker. Let's play that for you.
Thank you for calling Electrigo Motors. This is Sarah speaking. How may I assist you today?
Hi, Sarah. This is Michael Johnson. I just wanted to call and say how much I'm loving my new Electrigo Pulse. The driving experience is incredible.
That's wonderful to hear, Mr. Johnson. I'm thrilled you're enjoying your Pulse. Is there anything specific about the vehicle that's really impressed you?
The acceleration is amazing, and I'm getting even better range than advertised. Plus, the app makes charging so convenient. I can schedule everything from my phone.
That's fantastic feedback. We're really proud of both the performance and the app integration. Have you had a chance to try the new remote climate control feature?
Yes, being able to warm up the car while it's still plugged in on cold mornings has been a game changer. Oh, and the customer service has been excellent too. The technician who helped set up my home charger was so helpful.
I'm delighted to hear that, Mr. Johnson. We really strive to provide exceptional service throughout the ownership experience. Is there anything else I can help you with today?
No, that's it. Just wanted to share some positive feedback. You guys have really converted me to electric vehicles for life.
Thank you so much for taking the time to share that with us. It truly means a lot. Please don't hesitate to reach out if you need anything in the future. Have a wonderful day enjoying your Electrigo Pulse.
You too. Bye now.
Okay, so in case you're wondering, this is artificially generated from an AI. So I use 11 Labs for that. And if you're interested in that tutorial, then let me know in the comment section where I could, potentially create a tutorial on how to use that. But if you're also wondering, I've also used 11 Labs in a prior video together with Assembly AI, where we've essentially translated it to like different languages. So it's actually in the playlist that I mentioned right here. It's in this video. Code your own multilingual AI in Python that speaks 32 languages. So the speaking part is from the 11 Labs. Okay, so you'll notice that from the audio, it's essentially a hypothetical company, particularly an EV company selling cars. And so the customer is very happy with his experience of ownership. And he's just, giving a positive feedback to the call center agent. So yeah, let's go ahead and process the audio file here. So we're going to create a config variable where we're going to use the transcription config, and the parameters we're going to say we want to have speaker labels to be true, and we want the sentiment analysis to be true as well. So this will allow you to activate these functionality. So we're going to then use config variable in the following code block here. So first we're going to assign the transcriber function to a transcriber variable. And then we're going to essentially take the transcriber function and then we're going to transcribe the audio. So that is from the audio input. And recall that we've taken the audio input from the URL here. And then the config is provided here. And it will now know that it should, activate the speaker labels and the sentiment analysis. So then we assign that to the transcript variable, and we're going to perform the transcription. So this will take a short moment. All right, and it's finished. And so if you're wondering what it looks like, let's go ahead and type transcript. So you're going to notice that it is an assembly AI object. And you could type in a period and then you'll have access to, several other functions here. Like for example, the audio duration, 88 seconds. Let's have some more. And then you have what? You could access the audio URL, the config, the status, the summary, how many words were spoken. Okay, so it's essentially a list. So if you say list, you should get a more. Okay. Okay, I guess we have to extract that from here. Okay. Yeah, so that will give you all of the words. Let's just say here. So 253 words. All right. Now we're going to proceed to performing the speaker identification. We're going to use the utterances method here. Just append that to transcript. And then you're going to see a long list of what was spoken here in the text. And then where was it in the audio, at which particular, I'm not sure the unit. It's probably like millisecond. And then the identified speaker is provided here, and speaker equals to B. And then the words that were spoken, the individual words that were spoken here. And so it's very, minute in terms of the location of the timestamp of each word that was spoken. And then you could hop on to the next sentence, essentially. And so here we're going to essentially have a list of, what was the conversation about and who had spoken that through the identified speaker, whether it's A or B. Okay, so that's not really helpful to you, right? That, okay, you're able to identify speaker A or speaker B. So here we see, okay, speaker B says the following, and then speaker A says the following. So we're going to allow you to be better at that by replacing speaker B with the name of the customer and speaker A with the name of the agent. And so you're going to notice that we're essentially reiterating through the loop here. So from the transcript utterances shown here, we're going to take for each iteration, each line, we're going to extract the speaker, and then we're going to extract what was the spoken text. And then we printed it out. And then the next part here, instead of printing it out only, we're going to permanently store it into a list. So we're going to do the following. Okay. Yep, so yeah, we printed out here. The next, we're going to identify the number of unique speakers. So let's run this first here. And so in order to identify the unique speakers, we're using the Lemmer LLM model, and we're essentially asking the LLM model who is the speaker, and then we're iterating through. So we'll be able to know who is speaker A and who is speaker B. And the answer for who is speaker B is Sarah. And the answer for who is speaker A is Michael Johnson. So that is correct, right? If you go back to the script, you're going to notice that speaker A is Sarah and speaker B. Oh, no. Speaker B is Sarah and speaker A is Michael Johnson, as it is already mentioned here in the transcript. Okay, now we're going to map the identified speaker to the speaker A and speaker B. So you have already seen that the default speaker was labeled A and B. Now we have already asked Lemmer to identify the speaker. Now we know the name of Sarah and Michael Johnson. And then finally, we're mapping it, meaning that A is equal to Michael Johnson, and then B is equal to Sarah. Okay, so we're doing that here. And we're going to have it mapped. If you're wondering what it looks like, let's say you could, essentially type in the variable that was created to have a look. So here, B, Sarah, A, Michael Johnson. Print the transcript with speaker names. Okay, now we're gonna save it permanently into a list, the dialog list. Okay, so essentially similar to what we have done already above, where we identified the speaker to be just A and B, but now we're mapping it to the actual name. And so we have it here. And you'll notice that we've created essentially a list here. So let me just take out the dot here. Okay, type it in again. Okay, now we have it as the dialog list. So you notice that we've done the speaker mapping here, and then we're appending it into the dialog list by using the append function. And here we're using the f string, where we're going to take the speaker name right here, and then followed by what was mentioned, which is here, utterance.text. And so, yeah, f string will allow us to plug in pretty much variables into a string. And now we have the dialog list. Now we're going to, convert the list into a single string. So more data preparation. So we're going to do that. And then if you print out text, this is what it will look like. So it's one long stretch of string. And so with each new line, you're going to see a \n for the new line, like an enter. And while we're doing that, we're going to visualize the entities of the conversation. And here we're using the Spacey library, namely the displacy function. And in a few moments, you're going to see what it looks like. So here we're pretty much loading in the language model. So before the large language models, Spacey is pretty cool library where you could take, languages, corpus of text, and then you could analyze it pretty much visually. And it's really not like a large language model analysis, so to say. It's more into the traditional NLP, the natural language processing. So, yep, prior to the boom of LLMs, natural language processing is actually a thing. And yeah, you could essentially analyze the inherent composition of text. You could identify the entities that are present in the language, in the corpus of text or the body of text. And here it is identifying that. And when it's identifying that, it's also identifying the type of entity, like whether it is an organization, a person, an object, a day, etc. So yeah, a pretty cool way to visualize the conversation. And soon you're going to see another way to visualize the data. So we're going beyond just, looking at text from large language models as, simply text, but then we're converting it into a more tangible way on how we could visualize the data. So next, we're going to perform sentiment analysis. So for this, we're going to use the sentiment analysis method provided by Assembly AI. So you could just essentially append that, to the transcript variable. So type in transcript dot sentiment underscore analysis, and you're going to see this, printed out. So it's essentially the text, who spoke the text, and what was the sentiment, whether it was positive, neutral, or negative. Okay. So now we're going to take this and then we're going to give it some more structure. We're going to create a data frame. And now we have a data frame of 3 columns. The first column is the speaker, Sarah and Michael Johnson. Then we're going to have the column for sentiment, whether it be positive, neutral, or negative. But here you're probably going to see only positive and neutral because nothing negative was spoken during the conversation. And then the text that we have here for each of the, sentences from the 2 speaker. And then the last one, we have the index number. So there were pretty much 30 rows or 30 back and forth during the conversation. So now we're going to count the occurrence of each speaker sentiment combination. So the speaker and the associated text and the associated sentiment of that text that the speaker has spoken. And so we're using Altair, and then we're going to visualize it as a heat map. And so to do that, we're going to perform some data reshaping. And here we're grouping it by the speaker and the sentiment. And essentially, this will give us a visualization at the high level. Here we go. So at a high level, Michael Johnson has given a total of 10 positive remarks in terms of the sentiment. Sarah provided 12. For neutral, Michael Johnson provided 4, and Sarah spoke 5 for the neutral statement or sentiment. So this is a total of all of the 30 rows of identified sentiment. So each of the identified sentiment here are then aggregated into a 2x2 plot here. So in machine learning, you'll probably know the confusion matrix. So this is quite similar. So we get to know for each speaker what were the spoken sentiments. And then if we take it a step further and we analyze this in more detail. Okay, so, okay. This was actually, okay, all right. So I just, do it like that. Okay, the chart will be displayed here. Yeah, so the explanation is provided here. So I guess I should move this up here. Okay. I think that be more suitable place here. All right, so yeah. Okay, I think this is a more suitable reorganization of the cell. So yeah, as mentioned already, we're generating the heat map of the sentiment analysis here. And we're counting the occurrences of each speaker sentiment combination. So we have already, grouped it by speaker and sentiment as already mentioned. And then we're creating the base chart here. And then we're creating the heat map. And then we have the text, which are the numbers shown in here. And then we combine it all in one here, heat map plus text. And then we have this nice looking confusion matrix style heat map. And so I've already mentioned that we're going to take a step further and take a deeper look, create another heat map, so to say. So here we're defining the sentiment colors, positive with green, neutral with gray, negative would be red. And in a similar fashion, we're creating the base plot, the heat map. The text will go to the right, and then we're going to combine it together, and then we're visualizing it here. So we've run it. I think we've run it already. Yep. Okay. So here, you're going to see that first column is Michael Johnson. Second column is Sarah. I think this is pretty cool. I've never seen this before. So this is actually my first or a few ventures into visualizing the sentiment in terms of a heat map. And so, yeah, let me know how it goes and if you've seen this before. But I think it's pretty neat. So first column, Michael Johnson. Second column is Sarah. So you're going to see that here, Sarah is saying, thank you for calling electrical motors. So it has identified, the model has identified this to be positive sentiment. And then this is Sarah speaking is neutral. How may I assist you today would be neutral. And then Michael Johnson replied, hi, Sarah, this is Michael Johnson, which is neutral. I just wanted to say how much I'm loving my new electrical pulse, which is positive. And then the next one, the driving experience is incredible, also positive. And then we're going to see, like for the duration of the conversation, what was the sentiment of the bits or the pieces or the phrases, which is a collection of words, like 2 to 3 words, or sentence that are strung together. And what is generally the sentiment of that spoken, unit of text, if it's a sentence or few words. So you're gonna see that's why we have 3 fragments or chunks of sentences by each speaker at the same time here as a cluster, and it is identifying it uniquely, sentence by sentence, essentially, the sentiment for each sentence. And so pretty neat, I would say. And yeah, finally they ended with saying bye, and then it's identified as just neutral. And prior to that, the agent was thank you the customer, as essentially all positive sentiment here. And yeah, I mean, if you want additional resources, I've provided all of the documentation or additional reading on the sentiment analysis or speaker identification, as well as some, user guide on how you could customize the Altair data visualization plots, some more. And yeah, I mean, you could definitely use this for other use cases as well. Perhaps you could try uploading a Zoom meeting and seeing all of the identified speakers in a very, in multiple columns, all of the speakers, and then looking at each of the, sentence, and yeah, looking at all of the sentiment there. Let me know if that works. I haven't yet tried that, but I think it would be a pretty cool way to visualize the meeting. And so, yeah, I mean, if you like this video, give it a thumbs up, subscribe if you haven't already, check out the playlist that I provided in the video description. All of the code is provided in the GitHub repo. Links to that are provided in the video description. And so until next time, the best way to learn data science and AI is to build, build, build. And I'll see you in the next one.